And we're back. Okay, welcome everybody. Shout out, Riley. You're the only one out here. Shout out. Evaluate the Riemann sum with n equals 5 in the following equation by taking the sample points to be midpoints. And that's where the new piece was. Like, if I could have given this to you on the last quiz if I had said left or right endpoints. And now I'm saying find the Riemann sum for the midpoints. So what does that mean? That means I'm going to take the sum from n equals 1 for I equals 1 all the way up to n of delta x f of x, right? That is the definition of a Riemann sum. Okay, so that means I'm going to go from 0 to 5. I've got to calculate this delta x, though. Delta x is b minus a all over n. So in this case, it's 1, right? Delta x is 1. Okay, so that's what I'm going to continually keep multiplying by, right? 1 times delta x times, and there should have been a little I right there, but that's okay. 1 times f of xi, f of x1, f of x2, f of x3, f of x4, all the way up to 5. Now, I have to figure out what x1 is. Now, remember that x1 is going to change because I am using midpoints. X1 is going to change because I'm using midpoints. Remember, xi is really a plus delta x times I, right? That's really what our definition of xi is. Xi is equal to a plus delta x times I. Okay, what does that mean? That means that I'm going to take my starting point, I'm going to add on iterations of delta x to see what I need to plug in. Well, the good thing for us is a is 0. So this is really, xi is really, in this case, delta x times I. Well, delta x we just solved to be 1. So xi is really just I. Now, be careful here. I want to use midpoints. What do I have to do with that x value then? I have to cut it in half. See, like that would be if it was just left or right endpoints. I want to use midpoints. So I would normally say, okay, well, if xi is just I, then it would be 1. But if I want to use a midpoint, it needs to be 0.5, 0.5. Okay, that means x2 is going to add on an iteration of my delta x, right? So I want to add on another delta x, 1.5. x3 is 2.5. x4 is 3.5. x5, oh, there's 3 equal signs. Oops. x5 is 4.5. Do you need pass? Okay. I got 0.5 because I would normally say my rectangle was going from 0 to 1. Mm-hmm. But if I want the midpoint of that rectangle, I need to go up 0.5.
So you always have to get the midpoint of
if it says to, right? So you got to think about where would my rectangle end up, and then go right in the middle of that. So say your delta x was only 0.5. So I'm going from 0 to 0.5 for my first rectangle. That means my midpoint would be 0.25. Does that make sense? Mm-hmm. So it's basically just averaging my left and my right.
So if it didn't ask for midpoints, it would just be 1.
Then you would have to think about whether I want to use the right side or left side, draw it out, kind of what we did on our last quiz.
Got it.
All right, so now we have our 5x values. So I want to use f of x1, which is f of 0.5, right? I'll write this out. F of 0.5 plus f of 1.5 plus f of 2.5 plus f of 3.5 plus f of 4.5. Okay, that was kind of overkill there. I didn't really need to write that in there. Because what am I going to do with all of those values? Plug them in, right? I just want to plug them in. So it's 1 times, and honestly, why would I write that 1 times? It's just f of 0.5. So let's plug in 0.5. 0.5 squared minus 3. 0.5 squared, well, I'm not going to try to do that in my head. Excuse me. 0.5 squared minus 3 is negative 2.75 plus 1.5 squared minus 3, negative 0.75 plus, and then I've got 2.5 squared minus 3, and that's 3.25. And then I want to do 3.5 squared minus 3, which is 9.25. Same thing with 4.5, 17.25. Just adding those all up and then multiplying by 1. Okay, so we got negative 2.75 plus negative 0.75 plus 3.25 plus 9.25 plus 17.25. 26.25. Okay. That's my answer. So basically, the area underneath the curve can be approximate of x squared minus 3. Think about what that looks like. That's a parabola that has been shifted down 3 units. You know, it's interesting to point out here that if I go to graph this a little bit, just to sketch the graph to see what's happening, that means I go down 3 units, and here is my parabola. And I want to know going from 0 to 5, right? 0 to 5. So I'm going to start out like I have this area as well as this area, right? And obviously I should have gone out a little bit further because I'm going all the way to 5. But you get the picture here. I have 2 negative rectangles first before I start going into the positive direction, which makes sense because it's shifted down below the x-axis. And now I've got a couple positives going on to the right. And it escalates pretty quickly, right? Which makes sense because it's quadratic. The area is going to keep getting exponentially bigger there. All right, questions on that one? The tricky part about that, the new piece to that, kind of like two parts there. The fact that we're going to have midpoints, like that's different from what we had from our first quiz, the midpoint piece, which means that you got to figure out where your starting value is, where your first x1 is, and then go from there to find your other x's. And then also the fact that we could have negative area. You know, we didn't have that on the first quiz. It was all just positive areas. All right, let's take a look at number 2. Find the following integrals given the graph. All right, now notice here that each value is kind of compounding on itself, right? I'm going from 0 to 2, 0 to 4, 0 to 5, 0 to 7, 0 to 10. So I am just kind of accumulating my areas. I'm accumulating my areas. All right, let's take a look. 0 to 2. So I want this piece in there. Is that going to come out to be a positive area or a negative area? Negative, because it's below the x-axis. All right, so let's calculate that triangle. 1/2 base times height. 1/2 2 times 1, 2, 3, 4. So 1/2 base, which is 2, times height, which is 4, which gets me 4. Negative 4. Let's keep accumulating here. I want to now go from 0 to 4. So now I'm going to add in. So I've already got this. Now I'm going to add in that rectangle. It's a 2 by 4 rectangle. So I'm going to add on 8 more additional negative units. Because I had this triangle, and now I'm going all the way up to 4. So I've got this triangle plus this rectangle. All negative area. Okay, now let's go to 0 to 5. Okay, now I'm going to be adding on this trapezoid almost, right? I'm going to split it up into 2 pieces. So this is an area of 3, those 3 blocks, plus an additional, we got 1/2 base times height, 1/2 1 times 1. Now that's just 1 more unit, right? 1/2 base 1 times height 2. So 4 total units. I'm adding on 4 total units here. So it looks like I should be at -8. Oh, -8. We go from 0 to 7 now. Okay, I'm here at 7. Okay. So now I've got to add in this additional piece, more positive area to add in. Let me section this off like this. I'm going to use this square and then this triangle. Okay. So that square is going to give me 4 additional units, plus an additional, that triangle, 1/2 base 2, height 1, 2, 3. So plus an additional 3. So this gets me 4, this gets me 3, so an additional 7 units. Did you leave your phone? Yeah, there it is. Plus an additional 7 units, which gets me to -1. And now we go all the way to 10. Okay, so we've gotten all this. Oops, should be green. All this stuff now. Okay, so I've got one more triangle to add on. That looks like it's 1/2. Oh, same thing there, right? Base of 3, height of 2 now. So an additional 3 units. Looks like I should end with a +2. Just double check my key. Yep. You all good to go? Thank you. You can just leave it there. I'll get it. So again, I'm accumulating the area as I go. I keep adding the additional area as I continue on, as I keep progressing with my integral. Questions about number 2? All right. Let's take a look here. Now notice, look at numbers 3 and 4. Numbers 3 and 4 are the exact same equation, aren't they? But I'm telling you to do it in 2 different ways. The first way, I'm asking you to evaluate using the area. Basically the exact same thing that I did on the last problem, but I want you to graph it. I want you to graph it, and then calculate the area. And then the next one, I'm going to use our properties of integrals using the antiderivative. All right, so looking here, I want to go from -2 to +4 using this line 2x minus 4. Oh, slope is 2, y-intercept is -4. Okay. Slope is 2, y-intercept is -4. Rise 2, run 1. And I am going to go all the way to 4. You see that? I'm going to stop at 4. But I have to work backward down to -2. Down 2, left 1. Down 2, left 1. So that's the line. Basically, actually, that's the segment that I'm going to be using, right? Okay, I've got to evaluate the integral, which means that I'm going to have a piece of negative area plus a piece of positive area. Remember that you always go toward the x-axis. Okay, so let's calculate the negative area. Basically, this is 2 triangles, right? What's this visually? What's this going to end up as? Negative or positive? What do you think? Negative, because the negative piece is a lot bigger than the positive piece. So let's calculate the negative first. Well, the negative looks like I've got a 1, 2, 3, 4. 1/2 times 4 times my height of 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1/2, 4 times 8. Okay, so that is 16. And -16 is my red area, right? -16 is my red area. Let's calculate my blue area. My blue area, that's 1/2 base of 2, height of 4. So 4, +4. Okay, so when I evaluate my integral, what's it equal to? Total, -12. What should you get as your answer for number 4? Before we even do it, what should we have as our answer? -12. Okay? Because I've seen it based on the area here. So let's do it using the antiderivative now. That's what FTC2 basically says. Find the antiderivative, use the antiderivative with the f of b minus f of a to find what this is actually going to equal out as. Okay, so let's find the antiderivative. Well, that's 2x squared over 2 minus 4x, right? Which will be just x squared minus 4x, and I want to go from 4 to negative 2. Remember, antiderivative is jump it up 1, divide by that power, right? So I take that x to the first, make it an x squared, and I divide by the 2. And now I take f of b minus f of a. So which becomes f of b is 4 squared minus 4 times 4. And then minus the chunk of negative 2. Negative 2 squared minus 4 times negative 2. Let's evaluate each piece as its own. Okay, 4 squared minus 4 squared, right? So 0, that's weird, but okay. And then we have minus, okay, my right chunk is negative 2 squared minus 4 times negative 2, 12, okay, 0 minus 12. Oh, okay, that makes more sense now, negative 12. Okay. You need to finish both parts, right? Which part do you want to finish first? The white paper first? Put it back in. You've done it all.
No, you plug both. You plug 4 in as f of b, and then you plug in 2 for f of a.
Yeah, I took this, and then I took this.
Okay, so you're using the antiderivative for both.
Yep.
Got it.
Yep.
Just like the antiderivative.
We good there? Questions there?
Yeah.
Bueno?
Yep.
Okay, and so you know, if you get different numbers, something's wrong. All right, take a look here. Remember, there's this property of integrals where if you have, kind of the sum of two integrals equal the total, those areas are going to work the exact same way. So like in this case, look what I have here. I've got the integral from 0 to 10, 0 to 7, and then 7 to 10. You know that this plus this is equal to this, right? I mean, that just mathematically, that makes sense. From 0 to 7 plus 7 to 10 is equal to 0 to 10. That's basically like saying the area under the curve from 0 to 7 plus the area under the curve from 7 to 10 is equal to the area under the curve from 0 to 10. So it's kind of like composite area. Okay, so in this case, I can make myself a little equation here. I've got 0 to 10 is 8.5. 0 to 7 is 5.1. And I'm asked to find 7 to 10. Okay, we'll just subtract it over. 8.5 minus 5.1 is 3.4. So the integral from 7 to 10 of f of x dx, 3.4. Questions there? Okay. And if you miss any of this, again, I'm recording it, so you need to go back and watch. That's good.
Where's the link to the algebra on video for the quadratic?
For today, I haven't made it yet because I'm going to teach at 6. Use FTC1 to find the derivative of the function. Use FTC1 to find the derivative of the function. 3x squared from 1 to 3x squared minus 2 of 6 over 5 plus x dx. Now, what does this mean? That just basically means that, remember, FTC1 says that if you have the integral and the derivative, they are inverses of one another and they will cancel each other out. So if I find the derivative of an integral, I'm going to take d over dx, well, of that whole thing, right? That's going to cancel all this junk and that stuff, right? And then I'm going to have to take this and plug it right in for there. You know, I'm looking at this problem now, and I probably should have used 2 different variables. I think every time they did it in your book, they used 2 different variables to kind of remind you that they were different things, and I was plugging that 3x squared minus 2 in for x. But really, it means the same thing here. So this is going to end up being 6 over 5 plus 3x squared minus 2. Right? I'm plugging that in for x. I'm taking out x and plugging in my b value, what I'm going to for my integral. And then I have to multiply on. What am I going to multiply on? 6x. Good. The derivative of 3x squared minus 2. 6x. So let's reduce that a little bit. On the top, I'm going to get 36x. On the bottom, 5 and negative 2. Okay, so that's 3x squared plus 3. Right? Looks like I could divide out a 3. Let's reduce that a little bit. So on the top would be a 12x and then x squared plus 1. And that's all I can do. I wonder if I simplified that on my key. I did. 12x over x squared plus 1. Okay. So whenever you see the use FTC1, it's just basically saying, reminding you, okay, don't forget the derivative of an integral will cancel each other out because they're inverses of one another. And then just also don't forget to use the chain rule when you find the derivative of the integral, and then you apply what you're going to in your integral. You have to take the chain rule to that. All right, let's keep it going. Here's number 7. Evaluate the integral. Now, basically, I'm going to say you can evaluate it however you want, but I think the easiest thing to use is that FTC2, the f of b minus f of a thing, right? I think that's the easiest thing to do because this is pretty easy to find the antiderivative. Let's find the antiderivative. So that's 6x to the third over 3 minus 8x squared over 2 plus 5x from 2 to 5. Let's reduce it a little bit. That means I've got a 2x cubed minus 4x squared plus 5x from 2 to 5. Okay, this is f of b minus f of a. We'll plug in 5 and subtract away plugging in 2. Okay, plugging in 5. 2 times 5 cubed minus 4 times 5 squared plus 5 times 5 minus the entire chunk of plugging in 2. 2 times 2 to the third minus 4 times 2 squared plus 5 times 2. F of b minus f of a. When I say f, I'm talking about capital F, the antiderivative. All right, so let's plug it in. We got 2 times 5 to the third. To the third. Minus 4 times 5 squared plus 25. Okay, I'm just going to evaluate that real quick. 175. And inside the parentheses on the right, I got 2 times 2 cubed minus 4 times 2 squared plus 10. Oh, 10. Okay. So 175 minus 10 is 165. Just double check that. 165. Perfect. Questions about that? Okay? Evaluate the integral from 1 to 3 of 3 radical x dx. So you notice here this is just going to be a lot of the same type of question here all on the back. Just like the last one, evaluate the integral, evaluate the integral, evaluate the integral. And what I'm expecting you to do is just use the antiderivative every time. Okay, so we've got 3. I'm going to reduce this. I'm going to change it the way it looks. I'm going to say 3x to the 1/2 because that's the square root of x. So when I take the antiderivative, that's going to be 3x to the, okay. Sometimes I just like to use decimals a little bit better. So if that's 0.5, this is 1.5 divided by 1.5. Because in the end, am I assessing you on whether you know how to find an antiderivative? No. Like, if I made that fraction, I'd be able to reduce that out a little bit better, but who cares? I'm not concerned with that. I'm only concerned with finding the actual area under the curve. So 3 times 3 to the 1.5 over 1.5 minus 3 times 1 to the 1.5 over 1.5. Okay, so we've got 3 times 3 to the 1.5 divided by 1.5, 10.4 minus, and then we've got 3 times 1 to the 1.5 divided by 1.5. Oh, 2. So 8.4. Yeah, I said 8.39 in my key. Okay, same thing. Let's do some trig. Okay, you might need to brush up on your antiderivatives. That might be something to look at. Look at those tables of what is the antiderivative to each piece. Okay, so we want to find the antiderivative. 2 cosine x. What is the antiderivative of cosine? Positive sign, right? Positive sign. So 2 sine x minus, what is the derivative of, the antiderivative of sine? Negative cosine. So I'm going to go plus cosine x. There's my antiderivative. 2 sine x plus cosine x. And then we want to go from 0 to 2. Okay, so this is 2 sine 2 plus cosine 2 minus the whole chunk of 2 sine 0 plus cosine 0. Let's evaluate. 2 sine 2 plus cosine 2, 1.4. And then 2 sine 0 plus cosine 0. This is 1, isn't it? Yeah, 1. So this is 0.4. I mean, look at that problem. If I were to show you this problem at the beginning of the year and tell you, you would be able to do this, you'd be like, no way. No way. There's no way. This one. You might be thinking to yourself, I don't know how to do this now. Ooh, I think that this one looks like it's going to be a fun one. I thought we might have to do this. Okay, so let's take a look here. The first thing that I want to do is try to get it into something that looks polynomial. This is the tricky part to this one. You're going to be able to use FTC2 in the end. It's going to be nice and easy. The trick is getting it to be nice and easy. All right, so let's reduce this down a little bit. This x to the third plus 2x to the 6th over x to the 4th. Now, what do I mean when I say reduce it down? I'm going to write it like this. X to the 3rd over x to the 4th plus 2x to the 6th over x to the 4th. I'm going to break it apart a little bit. Because now that's going to be x to the negative 1 plus 2x squared. And that simplifies it a little bit more, doesn't it? That's the tricky part to that one, getting it to this, and now using the antiderivative. Now finding our capital F. Okay. What is the antiderivative to x to the negative first? You might be tempted to kick it up 1 and divide, but what happens when you kick it up 1? You get x to the 0. It's ln of x. Very good. So this is ln of, and you got to use ln of absolute value of x, but that actually doesn't play a role here because these are both positive. Ln of the absolute value of x plus, and then we have 2x squared. Okay, this one we do just go 2x to the 3rd over 3. Kick it up 1, divide. All right, now that's from 1 to 5. Yeah, x to the negative first, that's that weird one that you have to make it natural log. Because remember, the derivative of a natural log is 1 over x. So working backward, 1 over x turns into ln of x. Okay, let's plug in. Same rule applies though. See, at this point, this is easy. All I got to do is just evaluate. I got to take ln of 5 plus 2 times 5 to the 3rd over 3 minus the big chunk of, let me just swap it out. It's on my podium. Thank you. Minus ln of 1 plus 2 times 1 to the 3rd over 3. Okay, let's evaluate. I've got ln of 5 plus, I'll put this in parentheses, 2 times 5 to the 3rd divided by 3. 84.94. 84.94. And then I do the whole right chunk. ln of 1 plus, okay, this is the top, the numerator, 2 times 1 to the 3rd, but that's just really 2. Oh, this is just going to be 2/3, isn't it? Which is just 2/3, because ln of 1 is 0 anyway. So minus 2/3, or 0.6. I'll write it as 0.6. My other one was decimals. 0.67. Okay, so 84.94 minus 0.67, rounded. 84.27. Yeah. Questions about that? A couple more to go. The 11 and 12 are very similar. Sketch the graph and then evaluate given the area. So honestly, I'm kind of asking you to do the exact same thing as we have been doing on the last couple problems. But now I want you to use the graph to just kind of like to confirm your answer. Here's what I mean by that. Sketch the region enclosed by the given curves. Well, what is the region enclosed by the given curve? It's the square root of x. I'm going all the way out to 1, 2, 3, 4, 5, 6, 7, right? Where I have, okay, 0, 0, 1, 1, 1, 1, 2, 3, 4, 2, and then I would have 9, 3. So it's kind of like just a little bit below 3 out here. So what am I really finding here? Well, I'm finding that area. which is equivalent to saying the integral from 0 to 7, because I want y equals 0. Y equals 0 is the horizontal line, 0. So I have y equals 0, the square root of x, and x equals 7. So that's my enclosed region. So I want the integral from 0 to 7 of square root of x dx. And now I can use FTC2. Okay, so I have the square root of x dx. Well, that's got to turn into x to the 1/2, right? So x to the, I'm going to do it again. I'm going to say x to the 1.5 over 1.5. Just going to use decimals there. From 0 to 7. It's really like 2/3 x to the 3/2. But again, we're not really concerned about the antiderivative. I'm just concerned with the area under the curve. So it's 7 to the 1.5 over 1.5 minus 0 to the 1.5 over 1.5. Which essentially, this is all going to turn to 0, right? 0 to the 1.5 is 0. 0 divided by anything is 0. So we take 7 to the 1.5. We divide it by 1.5. We get 12.35. I would go and say minus whatever this is, but remember, 0 to the 1.5 is going to be 0. Divide by 0, or divide by 1.5, it ends up being 0 again. So that is my answer, 12.35. The weird part about this one, what makes this one different from the other ones is, A, you have to sketch the graph, and then use that graph. I'm not giving you the integral notation. I need you to come up with that integral notation for you to understand that, okay, here's my graph. That's what it should look like. Here's the antiderivative that I need to compute. One more of those. Sketch the region enclosed by the given curves and calculate its area. Okay, so it looks like I have y equals 0 again, my axis, y equals 0, and then 25 minus x squared. Well, what does 25 minus x squared look like? It might be better if you guys thought about it as negative x squared plus 25. Okay, that is a vertical shift up 25 units, right? So my y-intercept is like way up here. We'll just put it at 25. There we go. And then this negative tells me what about the parabola? Downward, right? I know that it's going to go like this. And I know I want this area. Okay, so that means that I need to compute that as the integral of this, I'll write it this way, negative x squared plus 25 dx. But where are my endpoints? Where are my endpoints? Well, I've got to figure out what these are. Well, how am I going to calculate that? Well, that's just the zeros of that parabola, right? That's just this. Okay, so add the x squared over to the other side. That's going to give me 25 is equal to x squared. So plus or minus 5 is equal to x, which makes sense. That must mean that's at negative 5, then positive 5. Which means that I want to take the integral from negative 5 to positive 5. And I can tell by the sketch, this is going to only be positive, right? All right, so let's take it. We got negative x to the third over 3 plus 25x from negative 5 to positive 5. Top minus bottom, f of b minus f of a, that's negative 5 to the third over 3 plus 25 times, 5, not 3. Minus the whole chunk of negative 5 to the third over 3 plus 25 times negative 3. Just plug. Oh, why did I do 3? Why did I do 3 again? Why did I do 3 again? I got 3 on the brain. Negative 5. All right, let's plug it in. Go to the calculator here. Looks like I've got negative and then 5 to the third. That negative's not really going to do anything because it's an odd power. Divide that by 3. And then add plus 25 times 5. Okay, that is 83.3. And then I add on, or sorry, not add on, subtract away, really. Now, think about it, negative, and then I have this negative 5 to the third power. That is now going to be a positive 125. Divide that by 3, and now I'm going to add on 25 times negative 5, which gets me another 83 and a third. Negative 83 and a third. I add, it's not 0. Be careful. You might be tempted to say that this is 0, that these are going to cancel out. That's not true. We can see that from the graph, right? This is only going to be positive. It's not going to cancel itself out. That's 166. Ooh. Tendency might be to say that would cancel out to be 0, and that's not true. All right. Well, that was fun. So long. Farewell.